This is BD Daily Tech News Podcast, your daily briefing on tech and innovation. It's 2026, March 13th, and today's theme is simple. AI compute is getting bigger, flatter, and more robotic.
Bigger, flatter, and more robotic sounds like my posture after a long Zoom week. But okay, are we talking new chips, new materials, or the rise of the fab floor androids?
All three. We've got Amazon saying it'll use Cerebras' giant chips alongside its own Trainium processors to run AI models. We've got a push toward glass substrates for future AI chips. And we've got STMicroelectronics planning over 100 humanoid robots in chip factories.
So the future is Amazon buys a pizza-sized chip, puts it on a glass cutting board, and a humanoid robot serves it to a data center. Love this for us.
Story 1. Amazon plans to use chips from Cerebras systems alongside its own Trainium processors, and the companies say the combo will better run AI software. Translation, AWS wants more options to serve and train models efficiently, without betting on a single chip design.
Okay, naive question. Why does Amazon need both? Isn't Trainium already the we made our own chip flex? Why invite a third-party monster chip to the party?
Because AI workloads aren't one workload. Think of it like a kitchen. Some dishes need a giant flat-top grill, high throughput, predictable patterns. Others need lots of burners, flexibility, mixed tasks. Cerebras is famous for wafer-scale compute, one huge chip that reduces the need to shuttle data between many smaller chips.
So instead of a bunch of roommates passing notes between apartments, it's one person in a studio apartment with everything within arm's reach, less hallway time.
Exactly. A lot of AI cost and slowness comes from moving data, memory bandwidth, interconnect bottlenecks, and synchronization overhead. A wafer-scale approach can reduce that for certain model shapes and inference patterns. Meanwhile, Trainium gives Amazon a vertically integrated option tuned to AWS economics and software.
I hear AWS economics, and I translate it to, we want the same AI, but with fewer zeros on the bill. What's the practical takeaway for developers? Do we code differently, or is it just pick a box in the console?
Near term, it's mostly procurement and platform choice. What instance type, what service tier, what latency and cost profile. But longer term, hardware diversity pushes software stacks to standardize. Better compilers, better kernels, and more portable model serving, so you can move between accelerators without rewriting everything.
So the dream is, I ship my model once, and it runs on whatever silicon is cheapest this week. Like airline tickets, but for matrix multiplication.
Story 2. Future AI chips could be built on glass. A South Korean company called Absolix is planning commercial production of special glass panels designed to make next-generation computing hardware more powerful, aimed at the newest and largest data centers.
I'm sorry, glass? Like Windows? Are we about to get a do not drop sticker on the entire internet?
Not the kind of glass you're imagining. This is about substrates and interposers, what the chiplets and memory stacks sit on and connect through. Imagine the motherboard layer in a supercomputer shrinking and becoming ultra-precise, so signals travel cleaner and power delivery is tighter.
So it's basically like upgrading the highways between neighborhoods, not just building taller buildings. Because right now, the traffic is the problem.
Right. For AI, performance isn't only compute. It's memory bandwidth, interconnect density, heat, and power. Glass can enable finer wiring and potentially better dimensional stability than some organic substrates, which matters when you're packing massive bandwidth between GPU-like compute and HBM-style memory.
And for normal people, this translates to your AI features get faster and maybe cheaper because the data center isn't wasting watts screaming across tiny wires.
That's the practical angle. Better packaging can mean more performance per watt and higher yield at scale, eventually lowering the cost per token for AI services. It also changes the supply chain. Glass panel production becomes strategically important, like how EUV tools became a choke point.
Okay, we've got giant chips and glass highways. Now give me the humanoid robots. Are they here to take jobs or just to take the night shift nobody wants?
Story 3. STMicroelectronics plans to deploy over 100 humanoid robots to handle repetitive tasks in chip factories alongside retraining, with the stated goal of avoiding closures. The headline isn't robots replace humans, it's automation plus reskilling to keep plants viable.
Humanoid specifically is interesting. Why not just normal industrial arms? Is this because factories are built for human-shaped hallways and human-shaped tasks?
That's a big part of it. A humanoid form factor can be useful when you're retrofitting automation into existing environments. Doors, carts, tools, and workstations designed around people. If the robot can use the same spaces and interfaces, you avoid rebuilding the whole plant.
So the robot is basically the universal adapter, like that one dongle you keep buying because your laptop keeps evolving faster than your life.
And chip fabs are all about consistency. Repetitive handling tasks can be a quality and safety risk for humans. Fatigue, contamination, tiny mistakes. If robots take the most repetitive steps, humans can move towards supervision, maintenance, and process optimization, assuming retraining is real and not just a press release hobby.
As a listener, I care because more stable chip supply, fewer production shocks, and maybe devices don't randomly get delayed because a factory can't staff a tedious station.
Quick recap. Amazon is mixing Cerebras wafer-scale systems with Trainium to broaden AI compute options. Glass substrates could unlock denser, faster interconnects for next-gen AI hardware. And STMicro is betting on humanoid robots plus retraining to keep fabs efficient and open.
And the vibe is the AI revolution isn't just smarter models, it's plumbing. Bigger pipes, better countertops, and a robot doing the boring parts, while we pretend we're all process optimization specialists.
If this helped, subscribe for the daily briefing. And in the comments, if you had to bet on one bottleneck easing first, compute chips, packaging materials like glass, or factory automation, what's your pick and why?
Also, if your pick is all three, that's valid, but you have to explain it in one sentence, like you're pitching it to a robot who's about to replace your job.